Hello, this is Dr. Oz. In this problem, in this video, I will show you a fixed cost problem using linear integer programming. So in this problem, I have three different types of products and three different types of materials, and each product requires different amount of materials. For example, solvent-based product will require, every ton of solvent-based product will require 0.5 tons of material 1, 0.2 tons of material 2, 0.3 tons of material 3. I don't have infinite resources, so I have 20 tons of material 1 available, 5 tons of material 2 available, and 21 tons of material 3 available for me. And the profit is given here per ton. So for example, cleaning fluid will give me $50 per ton versus solvent base will only give me $30 per ton. But to be able to start producing these three different types of products, I need to spend setup costs. For example, I need to spend $200 upfront setup cost for fuel additive, or $400 upfront for being able to produce cleaning fluid. And I have limited capacity. If I spend, for example, $400, that will give me only 40 tons of capacity for cleaning fluid. So let's build our model. And as usual, I have as usual three different components. The first component here is my objective. Second component is the decision variables, and the third component here is my constraints. Okay, so let's start with the first component, which is the objective. All right, so the objective here is to maximize profits, and I like to use green cell for my objective. And the second component is decision variables, and my decision variables are, in this case, tons produced, and also whether I would like to spend the setup cost or not. So these are two different types of decision variables for each product type. So I have these three products, right? So I have 2 by 3, 6 different decision variables. I would like to have yellow colors for those. And finally, I have my constraints here. And my constraint left-hand side values versus right-hand side values. And I have three constraints associated with material availabilities. And I have capacity constraints too for F, S, and C. So maybe I will just do maximum here type maximum F available, maximum S available if I decided to produce it, and maximum C available. All right. So I have 6 different types of constraints here, as you see. All right. So let's start with right-hand side values associated with material number 1, and I have 20 tons here available for me. Enter, and then drag it down. And here, maximum F is basically depending on whether I set up or not. So 50 tons will be available for me only if I set it up. So in this case, I have 0 because I have 0 setup. And same things here. I will have 25 tons only available for me if I spend setup cost for solvent base, which is S. And I will have 40 tons available only if I decide to go with clean fluid. And these are all less than or equal to constraints. And let's calculate left-hand side values. Material 1 usage is some product. the coefficients are right here, comma, the decision variables. And my material number 2 is similar, but I would like to lock my red array, so it's not gonna go down. And for maximum F constraint, basically I cannot produce more than right-hand side availability, but currently I'm producing this much. And S this much, and C this much. All right, now what I can do is I can run my model, but first I need to define, of course, my objective function, which is sum product my profits times my productions. All right, so let's start with our solver. If you don't know how to add solver, please watch my previous videos or just Google how to add solver add-in. Data, solver. My objective is my green cell, enter. My objective is a maximization problem. My decision variables are my yellow cells. And I need to add my constraints. In this case, I want these left-hand side values to be less than or equal to the corresponding right-hand side values. Enter and click OK. And another set of constraints that I have here is I would like to make sure that my decision variables associated with setup are binaries, 0 or 1. Click OK. All right. So before solving this, I would just click close, because I would like to make sure that my objective is created correctly, because coefficients times profits will take care of this profit per ton business, but it doesn't include really the setup cost. So I need to subtract sum product, the setup costs with associated setup cost decision variable. All right, so my objective function is pretty good. Decision variables are pretty good. Left-hand side, right-hand side values are good. So let's try to solve this problem to see what's going on. Let's click on options. And again, I don't want to spend more than 100 seconds for this and 100 iterations. Click OK. And now I'm going to solve this problem. And as you see, I got the best solution. So all constraint optimality conditions are satisfied. Let's get the answer. Click OK. As you see here, the maximum profit I can generate is $13.50. And to be able to do that, basically I need to spend setup costs for fuel additive and solvent base, but not cleaning fluid. And I will produce 25 tons of fuel additive and 20 tons of basically solvent base. And this number right here is actually 10 to the power negative 15, which is 0. Technically it's 0. And so you can see that the left-hand side and right-hand side values are given here. So there is no infeasibility. 20 is less than or equal to 20, which is material 1 is a binding constraint. Material 2 is not binding. Material 3 is binding. And you can see that this is 0 because I'm not investing in that. So that's it for this video. Until next video, enjoy business analytics.